Students, how are you all? Well, you are keep doing your studies in this weird scenario, I guess, and you are having your video classes with along your online classes, and thank you very much for that. Well, we are having the chapter 8, reflection of light. Today we will discuss a very important topic regarding this chapter. We will do some mathematical problem today. Well, in this chapter there are both convex and concave mirror. There are some mathematical issues that comes frequently in your exams, so we'll discuss it here. Okay, there is a equation for the mathematical issues. First, let me show what this is the concave mirror, this is center of curvature, this is half of principal focus. Well, if I put an object here, must be the image will happen here. In our previous class we have discussed it right here. Okay, so the image will happen here, something like that. This is A prime, B prime. So now see, this is object, so this is the distance of object from mirror, this is divided by u. This is the distance between image and the mirror, this is divided by v. This is focal length, this is divided by f, and this is radius of curvature, that is divided by r. I guess you all understood it. So then the formula is 1 by f equal to 1 by u plus 1 by v, and also f is equal to r by 2. And there's a very important issue, this sign convention. One, for concave mirror, u, f, r all positive. For convex mirror, u positive, r, f, v all negative. Okay, so we should remember and we should maintain the sign convention very strictly. Okay, now first mathematical problem. The radius of curvature of a mirror is 50 centimeter. Object is placed 30 centimeter away from mirror. Find image position and nature. Okay, now we will do the math. First, given radius of curvature, that's r, is equal to plus 50 centimeter. Plus means the sign convention, you have to follow it here. Okay, so r is 50, so f is 50 by 2 equal to 25 centimeter. Okay, u, object distance, away, so object distance u is equal to plus 30 centimeter. You don't need to change it from centimeter to meter, because here this is not necessary, but if you do, it's okay. Then v is equal to what? We know 1 by f is equal to 1 by u plus 1 by v. So to find v, so 1 by v is equal to 1 by f minus 1 by u. So we'll do it like that way. So 1 by v equal to f inverse 1 minus u inverse 1. So v is equal to f inverse 1 minus u inverse 1 inverse 1. Okay, now put the values here. Plus 25 inverse 1 minus plus 30 inverse 1 inverse 1. So we'll do it here. Inverse 1 plus minus 30 inverse 1, and then the result inverse 1. So v is equal to 150 centimeter. Okay, so plus the result is positive, so we can write image. So image is 150 centimeter away from mirror, and this is plus, nature is real and inverted. Also I can write position is in between C and infinite. Center of curvature and infinite. I can write also that. Okay. Other math. Before that, we have to know a thing, that means magnification. Then the definition of magnification is like that: the ratio of image and object length is called magnification. It is denoted by m and it has no unit. That's the very significant part. It has no unit. So m is equal to li by lo. Li is li image length, lo length. Okay, but there is a issue. Sometimes the math doesn't have those both those lengths, so then we have to find this formula like that way. V image distance, u object, okay. Now see what I'm talking about. Okay, an object is placed 20 centimeter away from a concave mirror. The radius of curvature is 45 centimeter. Find image position, nature and size mathematically. Given u is equal to plus 20 centimeter as per the sign convention, r is plus 45 centimeter. So f is equal to plus 45 by 2, that means 22.5. Okay, v is equal to what? Then m is equal to what? Because size goes to directly magnification. Okay, now we know 1 by f is equal to 1 by u plus 1 by v. So we have to find v plus 1 by v is equal to 1 by f minus 1 by u. So v inverse, sorry, v is equal to f inverse 1 minus u inverse 1 as it is before. 9 22.5 plus minus plus 20. Now we can have 22.5 inverse 1 minus 20 inverse 1 inverse 1, so minus 180 centimeter. V comes to minus. Now what does it mean? It means position, there's a virtual image position inside the, say, the mirror. Nature, this is a virtual mirror, that means virtual, and erect and size. Now we have to come to our magnification part. m is equal to minus v by u, so minus 180 u 20, so 9. So magnification is 9. The size, so m is greater than 1. Size means magnified. Okay, if magnification is greater than 1, that is magnified. Magnification is less than 1, that's diminished. Equal, that means equal. Okay, so what I've discussed about some mathematical issues about spherical mirrors, you must watch it very carefully to do the math sincerely. See those math again. Okay, what we have learned today. Today we first learned about the mathematical equation for spherical mirror, 1 by f equal to 1 by u plus 1 by v, and another is f equal to r by 2. That's we have learned previous class. What is u, what is v, and what is f? U means the distance of object from mirror, v means distance of image from mirror, f is focal length, r means radius of curvature, and then we came to our sign convention issue. Sign convention issue for concave mirror, UFR, that means object distance, principal focus or focal length, and radius of curvature all are positive. And for convex mirror, only U positive, rest of all are negative. So you have to follow this convention here. Okay. And so the first math were given like that. There's a concave mirror and the radius of curvature was 50 centimeter. The object was 30 centimeter away from the mirror, and find the image distance, image position nature. So the plus comes to the for sign convention, if is half far, so I give it, and if I have to find v. Now I put the formula and then I do the math as it is, as we do any math in algebra. So we get, so image is 150 centimeter away from mirror, this is plus, so that means nature is real inverted. So we can like another thing, the position is in between C and infinity, because C is 50, outside of 50 is infinite. So it is this. Then we came to our next important issue, that is our magnification. The magnification, the ratio of image length and object length is called magnification. It is generated by m, it has no unit. So magnification is something like that. Sometimes the image and object length is not given, so we write minus v by u. This is another formula to find magnification. So that way we had a math to do it. So the math is quite similar. Before, the object placed 20 centimeter away from a concave mirror. This concave mirror, the radius of curvature is 45 centimeter. So we put all the values. U is plus is sign convention, R is that, F is that. We have to find V, and for size we will find the magnification. So we do the math and we find V minus. This minus is very significant. That means it's a virtual image, and that's why like I write virtual and erect, and we find the magnification. So we let the size magnified, because m is greater than 1. Okay, this all for today. I guess you might understood today's topic and watch the video very carefully. Let you know very important significant math next. Okay, well, if you have any problem to understand this math, just leave a comment in the comment section. Also, you have a you have a option to discuss discuss it in your online class also. Okay, that's all for today. Allah Hafiz.